Hey everybody, this is Larry. This is me trying to do week 5 of the Leetcode weekly premium challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. Oh man, I was hoping that I haven't done I don't remember these, so sometimes I hope that I haven't done it. But apparently I did this one in 2019, which is a long time ago. Alright, let's see. We have 12 dirty toss strange coins. You have some coins. The I coin has a probability of eye of facing heads when tossed. Return the probability that number of coins facing head you goes to target if you toss every coin exactly once. Okay, I mean this is straight up a dynamic programming problem, right? And this is actually a very common thing that you actually want to do in real life sometimes. Like, you know, instead of maybe figuring out certain things analytically, you could do it, this way, right? Computationally, which is fine. I mean, this is just the way that you should think about it. It is that it is what can we call it? Man, I am so bad at words today. The way you should think about it is that this is a pseudo polynomial algorithm. Though this isn't quite so not, but the way that I think about it is more like a knapsack, right? Where okay, you try to figure out how many ways are there. Like the way that you break it down is say, okay, given one coin, how many ways are there to get one head or 0 heads, right? And then given 2 coins, how many ways is there to go from 0 head, 1 head, 2 heads? For 3 coins, 0 head, 1 head, 2 head, 3 heads. And once you kind of say it that way, then the transitions for the graph, for the dynamic programming, for the nodes, for the states, should be relatively easy to visualize. And I do advocate, I always have a notebook on me, but this problem I've done enough times that I don't need it, but definitely it is something to consider just for visualization, right? And once you kind of get familiar with that, then you realize that you can make optimizations, like space optimization and stuff like that, right? So yeah, how do I want to write this? I don't remember where I can do this if one array or do I need 2 arrays? But I'll just do 2 arrays anyway. But yeah, so then maybe you could, yeah, I mean, so yeah, and I'm maybe prematurely optimizing it for the people at home, so maybe I shouldn't do that. Another way of thinking about it is just like what I said. Then you can do it top down, right? So let's actually just do it top down. I find these not often, but enough times that it's easy for me to mathematically doing it bottoms up. But definitely, if you're stronger bottoms up, try to do it top down. If you're stronger top down, try to do it bottoms up. Just get some practice. And yeah, and this one, the way that you get is maybe get prob. I'm lazy, right? You have index, which is the number of coins you flipped, or this is the current coins that you're flipping, and the number of current heads that you have, right? So then now, if heads is greater than target, then you just return 0 because, I mean, you already gone over it, right? Otherwise, yeah. If index is equal to n, then if heads is less than target, we return 0. Otherwise, we return 1.0 because then you have 100% chance of hitting it. Otherwise, then now you have only 2 choices, right? Now you flip this index coin and you either get a head or you don't. So here, basically, I mean, guys, this is probability theory, and you have to know probability theory a little bit. It's not a difficult probability theory, but it is, I mean, you just have to do it. And yeah, I mean, I think that's it, right? So basically, the probability of you getting heads is this, yeah. So getting heads is going to be, you go to this times get the probability of the next state, which is index plus 1, heads plus 1, plus the inverse probability of that, because now you flip the tail, times the get probability of index plus 1. Heads doesn't change because tails, well, you know, because tail, you got a tails, right? So it's just returning this, and that's pretty much it, right? Now you could do get prob 0 0, and should be okay. Let's give it a quick spin. I know I have to do memorization, but let's just give it a quick spin anyway. So it looks okay. The thing is that, of course, if you do something a little bit bigger, and this is actually a little bit annoying to do a little bit bigger, but let's just say 100, and then you have how many is this? Is 5? 10, 20, that's 40, 80, no, 60, 80, 100 maybe. Whatever, it's big enough, right? So in any case, this will time out is my point, because you know, we every time we record this, it branches out, you know, the two things, right? Yeah. So of course, then here we add memorization. What can index be? Well, index can go from 0 to n. Heads can go from 0 to target, which is also maybe n-ish, right? I mean, it's less than or equal to n, but you know. So in the worst case, it'll be n. So here we just have to allocate space for this, and I always kind of write it this way, at least on the daily problems, because it's easier to show. But you have has cache, right? Another way of thinking about memorization is just caching it, because every time you give it the same input, you get the same output, right? So you don't have to calculate it anymore the second time you do it. So okay, so then now you have has cache is equal to force times on the inside it's going to be head, so that's going to be target plus 1, right, n plus 1, and then cache will just be, I don't know, I just go with none, it doesn't matter. And here now then you can just add the caching, which is that if has cache of index heads, then we just return the cache. So we have the cache, we use it. Otherwise, yeah, we have the results is equal to this. We save the results. We set the has cache to true, cache index heads to this results, and then return results. That's pretty much it, really. Give a spin. You see it's much faster. I guess it makes sense that this is, you know, because you have to do 100 things in a row pretty much. So yeah, anyway, I'll give it a quick submit. And yeah, you know, what's the complexity here, right? Well, the number of possible inputs, it's going to be n times target, which is in the worst case n square, of course. Though you could, there are also probably like things that you could do to branch off if you really like, you know, in tune with the maths, but it's fine. But yeah, it's going to be n square number of possible inputs, and each input will take all of one space and all of one time. So it's going to be n square or n times t, where t is the target, time and space. And of course that is pseudo polynomial because it is pseudo polynomial in t, right? But I guess it's just n square. I don't know what I'm talking about anymore. I'm tired, so that's all I have for today. Thanks for watching. This is for interviews, I think this is a very fundamental problem. You may not need to know, like, I mean, I don't know. Every component of this you probably should know for an interview. So, yeah, like even the probability is very elementary probability. So, and also it's probably good in life in general. It's like one of the things that is actually pretty useful. So, yeah, that's what I think. Anyway, that's all I have for today. Let me know what you think. Yeah. Thanks for watching. Stay good, stay healthy to good mental health. Have a great week, everybody. I'll see y'all later and take care. Bye-bye.